Hello, my name is Oscar Hernán Giraldo. I am from la Universidad Nacional de Colombia, sede Manizales, and I will share with you our work on copper hydroxysalt polyphenols functionalized calcium caseinate films for the development of antimicrobial and antioxidant food packaging. Everybody knows that conventional polymers have a lot of environmental problems. A good alternative to these materials are protein-based biopolymers, such as calcium caseinate. However, they have some problems like they are susceptible to microbial growth and they don't have very good mechanical performance. This is a limitation for their use in functional packaging or coatings. Our idea was to enhance calcium caseinate film by incorporating copper hydroxynitrate functionalized with gallic acid, a polyphenol known for its antioxidant and antimicrobial activity. We prepared the copper hydroxynitrate materials by a simple precipitation method using calcium hydroxide, as you can see in the scheme. After we obtain the material, we make a functionalization with gallic acid by a direct and simple method. Finally, we incorporate the functionalized materials in the films by a film casting method in concentrations of 1, 2, and 4 weight%. Here you can find the details for the characterization and the measurement of the different properties of the films. The characterization by X-ray diffraction shows the typical pattern for the copper hydroxynitrate material, which is a layer material. This distance is about 7 angstroms, which show that we successfully obtained the material, but also when we make the functionalization, we change these nitric ions by the gallic acid. We can see here in the XRD pattern that the layer has an expansion, which suggests that the gallic acid goes inside between the layers as an intercalated material. The scanning electron microscopy showed an important change in morphology after the intercalation of the material. We can observe the material that is more compact than the original copper hydroxynitrate. This is another evidence that we get a successful functionalization of the material. Now, when we observe the film morphology, in the original calcium caseinate films, we observe a very smooth surface, but after the incorporation of the copper hydroxide nitrate functionalized with gallic acid, we can see some texture in the surface that corresponds to the copper hydroxide material that is not fully incorporated in the film. In figure 4 and 5, we can observe a significant increase in the mechanical properties, particularly with the films that has concentration of the functionalized materials at 1% and 4% when we compare with the original calcium caseinate film. The Young modulus also shows a significant increase. The incorporation of the functionalized materials into the films also have a positive impact in water solubility and the degree of swelling. We can observe here that the incorporation of the filler reduces in about 50% the solubility of the films, which is good for packaging application, and we also have a 50% reduction in the degree of swelling. Finally, we have that the films with 1% of the filler have the best antimicrobial performance. At higher loadings, this effect decreases slightly due to particle saturation that limit the copper ion release. These results show that copper hydroxide functionalized calcium caseinate films combine mechanical reinforcement, reduction in water sensitivity, and antimicrobial potential. Thank you very much for your attention.